Hello and welcome to our website. I'm very happy you found your way here. This is a brief introduction of apic.ai as a company and of the services that we offer. To summarize what we do in short, we have developed a visual hive monitoring technology which can be applied to honeybees as well as bumblebees, and it is using networked sensor technology as well as artificial intelligence to analyze the behavior and the visual data that we collect in the hives. When I say we, I refer to a team of currently 12 people, and we are three founders, Frederik Tausch, who is responsible for the software part and especially the machine learning algorithms, Matthias Diel, who is responsible for hardware design as well as production, and myself, who is responsible for the non-tech related parts of the business, and as well as the bit of beekeeper expertise that I bring from having 3 hives of my own. I first got into contact with the problem of the perishing of bees when I myself became a beekeeper a couple of years ago, and I looked at the issue from a scientific standpoint and noticed that it's not so much a lack of wanting to change something about the underlying causes, but much rather a lot of confusion regarding what can be done and what the underlying issues are. How do they interrelate with each other in this very complex system which nature is? And consequently, apic.ai was born, and the idea was to use the latest technology to allow a closing of this research gap and to gather sound data which can be used to derive information about these causal relationships and ultimately help develop efficient countermeasures. So how can technology turn bees into biosensors? We have a sort of a 3-step process. At first, we detect all the individuals on the images that we take, because each video is made of a lot of frames. We detect each individual on each frame. And in the next step, we track the motion by understanding that the bee was in one spot at one time, and in the next frame it's in the next one. And so they travel through the image, and we track them while they do it, and that allows us to ultimately see how many bees are going into the hive and how many are leaving, and how many are maybe just like turning around and going back out. The third step is the derivation of specific features on the bee. Like in this case, it's the pollen, which allows us to do further assessments. Regarding honeybees, data we have collected so far is data on flight activity up to a point where we want to be able to detect the loss of foragers. So we're tracking all the bees going in and going out, and if we can achieve, which is still in development, a very, very high accuracy, so we can detect like almost every single bee and there's almost 0 error, then we would be able to detect a loss of foragers, which could be used as an indicator for mortality in the field. We also are able to quantify the pollen collected on the bees and also the share of pollen foragers as opposed to those bees who are entering without pollen on their legs. Fields of applications we have been using the technology in was the testing of sublethal effects of plant protection products in field studies as well as tunnel studies. We have used it as an automated assessment tool for checking whether colonies are similar before there is an ecotoxicological study, as well as for the detection of temporary shortages in feed availability, and the exposure assessment in tunnel studies. So are the bees actually feeding from the plants, or are they just in the tunnel but they stay away from them? Similar data can be collected for bumblebees, that is also flight activity, the foraging activity, a loss of foragers, which is a lot simpler because there's not as many bumblebees as there would be honeybees, the queen activity and the number of queens leaving a colony, which is a ecotoxicological endpoint, and this is detected by the size of the bumblebees, which is changing over the course of time, and we're also detecting that. Fields of application are the assessment of the pollination activity in general, also as a performance indicator of how much is being pollinated. Also the testing of sublethal and lethal effects of certain plant protection products, an automated pre-assessment of the similarity of colonies, and also an automated assessment of the number of bumblebee queens as an endpoint, so nobody has to count them anymore manually in general, but we can just automate this process. One of the main advantages of technology is that a lot of the data collection can be done by a machine and doesn't need a human anymore, which is better qualified to do higher level jobs. And so we can automatically count the bees or the bumblebees which enter or leave a hive. And we can do this also in remote locations because we can power our systems with solar panels. We get 24/7 insights rather than just snapshot data or samples. We can parallelly collect data at any number of hives and colonies at the same time. And the correctness of the measurements that we take can be checked afterwards because we have the results and we also have the video footage and we can check whether it's correct. We have collected some experience in studies we have already been doing or are doing right now, for example with Eurofins, Bayer or the city of Karlsruhe. And in these studies we have generated data for ecotoxicological tests prior to the market approval of plant protection products. We have observed factors influencing the activity and the pollination activity under field conditions in order to improve agricultural practices. And we have also collected reliable data to test certain specific assumptions and hypotheses regarding the causal effects behind the perishing of insects, for example, temporary food shortages in an area where the bees live. If you are interested in doing a study with us, or you have questions regarding the research we've done so far and you would like to know more about it, or you would like to know how much a study costs, please give me a shout, write an email to Katharina at apic.ai and I will give you all the information that you may need. Thank you.